Welcome back to the STEMverse Academy. If you're watching this, you probably tackled basic integration, substitution, maybe even definite integrals. But today we're cracking a new code, integrating rational functions using partial fractions. Sounds fancy, but really it's just algebra. Let's say you have an integral that looks like this, right here on the screen. So you can't use basic rules. You can't do u sub easily. So what do? We break that fraction into simpler fractions called partial fractions that you can integrate. So we're basically saying this looks messy, and we're going to make it into smaller, simpler pieces. So use partial fractions when you're integrating a rational function, a fraction of two polynomials. The degree of the numerator is less than the degree of the denominator, and the denominator can be factored. If the numerator's degree is higher, divide first, polynomial division. So here we're going to solve this integral, we're going to start by factoring the denominator. So here the denominator is x squared minus x minus 2, and that, when we factorize it, is x minus 2, x plus 1. So now we're going to rewrite it inside of our integral. So we're going to remove that integral sign, and we're just going to write it like this. So it's going to be 3x plus 5 over x minus 2 and x plus 1. And you're going to write a over x minus 2 plus b over x minus 1, or x plus 1, sorry. And now we're going to multiply both sides by the denominator. So here this is going to be 3x plus 5 now, because we're multiplying by the denominator on both sides. So 3x plus 5, and then it's going to be a times x plus 1 plus b times x minus 2. And now we are going to expand those. So 3x plus 5 still is equal to a to the x plus a plus b to the x minus 2b. Now we're going to put it in brackets and just simplify a little bit. So 3x plus 5 equals the x coefficients here, so a plus b. And then in this bracket, we're going to put the constants, so a minus 2b. There you go. And now the next step is going to be comparing coefficients. So we're going to compare this side of the equation with this side of the equation. So here the x's is 3 equals a plus b, because we have a 3x here, and here we have a plus bx. So that's going to be one equation, and the second equation is going to be 5 equals a minus 2b. Now we have to solve these equations. There's multiple different ways you could choose to do this. This is just algebra, so we're going to just subtract the second equation from the first equation. So we're just going to do that, and we're going to get 3b equals negative 2. And then when we solve for b, we're going to get b equals negative 2 over 3. So we found what b is. Now we have to find what a is, and to do that, we're just going to plug in b for one of the equations. So if we plug in b for one of the equations, then we're going to get a equals 3 minus b. So here I'm plugging it in for this equation. I'm just plugging in negative 2 over 3 in this equation. So a is going to be equal to 3 plus 2 over 3, which is 11 over 3. So we have our a and b values. So now we're just going to rewrite our equation, our integral here. So the integral was 3x plus 5 over x squared minus x minus 2 d of x equals the integral of 11 over 3 over x minus 2 d of x plus the integral of negative 2 over 3 So just in case you're a little bit lost right now, all I did here was up here we had our equation right here. So I just plugged in the a value that we found in here, and then the b value that we found in here, and that's all I did so far. And then I just added the integral sign. So that's what we're doing right now. And now we just have to solve these integrals, which are now very easy for us. So now we can just write it like this. And these integrals will be 11 over 3 ln of x minus 2 plus, or it's going to be negative 2 over 3 ln of x plus 1 and plus c. Don't forget that plus c. So if you didn't see that, how I got ln of x, all I did was I pulled out this constant out front, because this is just a constant right here. I just pulled it out of the integral. And then I also taught this in my last video too. So I just pulled this out front right here. And then whenever I pulled that constant out, I was just left with 1 over x minus 2. And that's just ln of x minus 2. Same thing with this one. I pulled this constant out. And then I was left with 1 over x plus 1, which is ln of x plus 1. So that's how I got this here. And that's going to be our answer for this partial fraction problem. They are quite long, so I'm only going to do one in this video, but as you can see, it's not too hard. It's just long. So some tips for whenever you guys are doing this on your own is to check your factoring very carefully. One wrong sign can throw everything off, and you're going to get the wrong answer. And always simplify first. Make sure you simplify before doing your integration. That's very important. Now, if you want to do some practice and you want to see if you got this, grab the free episode 4 worksheet linked below with guided problems and solutions to help lock this in. And that's it for partial fractions. Next time, we're going to be tackling some new problems on integration, so make sure you check out that video. And if this helped, hit that like button, subscribe, and turn on notifications so you don't miss the next lesson. This is the STEMverse Academy, where we break STEM down one step at a time. See you in episode 5. Have a great